Hello everyone, myself Shubham Shiv. Today I am going to discuss about very interesting topic, hyperconjugation effect. Before going to start hyperconjugation effect, I want to discuss one question to make you realize how the important hyperconjugation topic is. Arrange the following in the increasing order of rate of electrophilic substitution reaction. What is electrophilic substitution reaction? A chemical reaction in which electrophile substitute a functional group, typically a hydrogen atom, is called electrophilic substitution reaction. We can take one example like electrophile will attack on benzene ring and substitute one hydrogen atom and make this product. We are not going to discuss the mechanism of electrophilic substitution reaction. So, higher the electron density in the ring, higher will be the rate of electrophilic substitution reaction. On the basis of plus I effect, we know that the order of plus I effect among these, the T-butyl group has higher plus I effect group, then isopropyl or we can also write as a then ethyl group, then methyl group. So T-butyl group has higher plus I effect. So it will push more electron density into the ring. So the order of electrophilic substitution reaction is like D, then C, then B, then A, because the order of plus I effect is like this. So on the basis of plus I effect, the answer is this, but this answer is wrong because there is a role of hyperconjugation effect. We will come back on this question after discussing the hyperconjugation effect. Before going to discuss the mechanism of hyperconjugation effect, I want to introduce about alpha hydrogen. What is alpha hydrogen? Take an example like of the carbon attached with a functional group is called alpha carbon. Functional group may be ketone, the carbon attached with a functional group is called alpha carbon. So this is alpha carbon and here this is alpha carbon. Take more example like ethene, alkene. So this is functional group, this is alpha carbon, and the hydrogen attached with alpha carbon is called alpha hydrogen. So here how many alpha hydrogens? 3. Here alpha carbon and this is alpha hydrogen, this is alpha carbon and this is alpha hydrogen. And similarly here This is alpha hydrogen, this is alpha hydrogen. In this case, in this example, this is alpha carbon. In the case of hyperconjugation, we only focus on alpha position. There is not any kind of role of beta position. So we only look at the alpha position. Find the number of alpha hydrogens. So this is functional group. The carbon attached to a functional group is called alpha carbon, and the hydrogen attached with a alpha carbon is called alpha hydrogen. So how many alpha hydrogens are here? 3 and 2, 5. And here only 1. And in this example, here 3, because this is CH3 group, this is also CH3 group, and this is also CH3 group. So how many alpha hydrogens are here? 3, 3, 3, total 9. And in this example, how many alpha hydrogens for this alkene? CH3, CH3, and this is CH2 group. 3, 3, 6, this is also alpha position. Then total 8 alpha hydrogens are here. Now I am going to start what is hyperconjugation. This effect is nothing but this is just conjugation of sigma bonded electron with p orbital or pi star orbital. Take an example of ethyl carbocation. This is empty p orbital. Carbocation is an electron deficient species. So it wants to electron, it needs electron density to gain stability. So what it will do? It will interact with alpha CH bond. This empty p orbital, carbocation has empty p orbital, so it will interact with alpha CH bond to gain more stabilization. So what will happen? This CH bond will break, and there is a formation of new pi bond between these two carbon. This structure is called hyperconjugative structure. This empty p orbital will interact with alpha CH bond, and this CH bond will shift here and form a new structure which is called as hyperconjugative structure. And hyperconjugation effect has another name. There is no bond between this carbon and hydrogen. So this effect is also known as no bond resonance. No bond resonance. Why resonance? Because there is a conjugation of electrons. So all the CH bonds are equivalent. So each CH bond will show hyperconjugation effect. To distinguish the hydrogen, we can give different number H1, H2 and H3. Here what will happen? CH1 bond will break and form this structure. So this is H1, this is H2 and H3. We can also take CH2 bond. So CH2 bond will break and form this structure. And CH3 bond also break. So how many hyperconjugative structures are there? So there is a formula, number of hyperconjugative structure. It is equal to number of alpha hydrogen plus 1. This is the simplest formula to calculate the number of hyperconjugative structure. So how many hyperconjugative structures are there? First see how many alpha hydrogens are there. 3, 1, 2, 3. So 1, 2, 3. Here 3 structures, 3 alpha hydrogen plus 1. What is this one? This is the original structure. In the case of hyperconjugation, we also count the original one. We also consider as a hyperconjugative structure the original structure. Now we will see the example of alkene. Here sigma 2 pi, empty pi, this is filled and this is empty. Sigma 2 pi conjugation happens. In the another example, sigma 2 pi star conjugation. Take example of any kind of alkene like this. Whenever pi bond forms, along with pi star molecular orbital also forms. So C double bond C has one sigma bond and pi electron density. This is pi, this is empty pi star. So whenever pi bond formation take place, along with two molecular orbital forms. One is pi, which is filled, and pi star, which is empty. So this is functional group. The carbon attached with the functional group is called alpha carbon, and this is alpha hydrogen. So it will also interact with this empty pi star orbital. Alkene has empty pi star orbital. So this sigma CS sigma bond will shift here, and this pi bond will break and form a new hyperconjugative structure. Similarly, these two hydrogen also show the hyperconjugation effect. So how many hyperconjugative structures are there? 3 alpha hydrogens plus 1. We are also counting the original structure. So 4 hyperconjugative structures are possible there. Find the number of hyperconjugative structure. So find the total number of hyperconjugative structures. So number of hyperconjugative structures equal to number of alpha hydrogen plus 1. So first we are going to count number of alpha hydrogen. So this is functional group, this is alpha position, so this is alpha hydrogen. So 2 alpha hydrogens are here. So total number of hyperconjugative structures 2 plus 1 3. And how many alpha hydrogens are here? 3. This is CH3 group, this is CH3 group. 3 3 6. So total number of hyperconjugative structures 7. And here 3 4 12. So 12 alpha hydrogens. So total number of hyperconjugative structures 12 plus 1 13, because we are also counting the original one. And here 3 3 3. So total 9 alpha hydrogens. So 9 plus 1 10. 10 total number of hyperconjugative structures are formed here. And here only 1 alpha hydrogen. So 1 plus 1 2. 2 hyperconjugative structures. Here 1 alpha hydrogen and 2. So 2 plus 1 3. We don't count this hydrogens because this is beta position. We only look at the alpha position.